Imagine you have a futuristic kitchen, a super smart AI chef. We'll call it AstroChef. You tell AstroChef you're hungry. You give it access to your refrigerator. It sees eggs, it sees flour, it sees leftover vegetables. It sees a mystery sauce from last week. You leave the room. You come back to the table and there is the most delicious, perfect omelet you have ever tasted. It's fluffy. It's flavorful. It's got a certain cosmic flair. You are absolutely amazed. This is the best breakfast of your entire life, and you have no idea how it was made. You just know that it worked. This scenario is a lot like how we interact with artificial intelligence every day. We give it an input, a problem to solve. Find me the fastest route home, we ask our phone. Recommend a movie I'll love, we tell our streaming service. Is this a picture of a cat or a supernova? We ask a photo app, and just like our AstroChef, the AI processes this request in a way that is hidden from our view. It takes the data we provide, works its magic, and presents us with an output. The result is often impressive, sometimes surprisingly accurate, occasionally a little bit weird. The crucial part of this story isn't just the delicious omelet. It's the moment you try to figure out the recipe. You ask AstroChef, "How did you make this?" And it can't tell you. It can't write down a list of ingredients in order. It can't explain why it chose a pinch of paprika instead of a dash of thyme. It just knew. So what exactly is this black box? Think of it like the human brain. Your brain is performing trillions of calculations right now. It's keeping your heart beating. It's processing the light hitting your eyes so you can read these words. It's connecting these concepts to your existing knowledge of the universe. Now try to explain, step by step, exactly how your neurons fired to understand that last sentence. You can't. You can describe the feeling of understanding, but you can't map the precise biological pathway. The process is a black box even to you. Modern AI, especially deep learning and neural networks, works in a similar way. These systems are inspired by the structure of the brain. They are built with layers upon layers of interconnected neurons. When we train an AI, say, to recognize a dog, we show it millions of pictures of dogs. Each layer of the network learns to identify different features. The first layer might learn to see simple edges and colors. The next might combine those into shapes like ears or a nose. Deeper layers might combine those shapes into a dog-like concept. The complexity is where the mystery begins. A powerful AI can have hundreds of layers and billions of connections or parameters. The AI adjusts the strength of these connections on its own as it learns. The final network of connections is what holds the knowledge. You might be thinking, this is 2025. If the AI is so smart, why don't we just build another AI to explain what the first one is doing? And that's a great cosmic-level question. Scientists are actually trying to do that. But the problem is a bit like trying to translate a poem written in an alien language. Let's say an AI is used to approve a bank loan. A human would say, "The applicant has a high credit score, a stable job, and low debt, so I'll approve the loan." The AI, on the other hand, processes thousands of data points simultaneously. It weighs the applicant's age, zip code, transaction history, and countless other variables in a complex mathematical dance. The final yes or no emerges from this high-dimensional calculation, not from a simple checklist of reasons. Asking this AI why it denied a loan is incredibly difficult. It can't point to a single reason. The answer is tangled up in the subtle interplay of all those variables. It's all statistics and probability, not conscious reasoning. The good news is that we are not content to live in the dark. The universe is full of mysteries. What do we humans do? We build bigger telescopes. We invent new tools. The same is happening in the world of AI. An entire field called explainable AI, or XAI, is dedicated to prying open these black boxes. Scientists and engineers are acting like cosmic detectives. One popular method is like creating a heat map of the AI's attention. Ask an AI to identify a cat in a photo. The technique highlights the pixels it looked at. Another approach: build simpler, more transparent models to approximate the complex one. Think of it like, you can't read the AI's giant, complex novel of a brain, so ask it to write a short story. Scientists also design AI that is interpretable by design. Instead of building a black box then peeking inside, build it with glass walls from the start. It's like choosing a slightly less powerful rocket engine you can fully diagnose over a mysterious, more powerful one. For critical applications, safety and transparency are paramount. Why does all this matter? Because we are weaving AI into the very fabric of our civilization. These systems are no longer just recommending songs, driving cars, diagnosing diseases, managing our power grids, influencing financial markets. They are becoming the invisible infrastructure of our future. As we hand over more responsibility to these artificial minds, understanding how they think isn't just a cool science project. It's a matter of safety, fairness, progress for our species. Our journey with AI is a journey of discovery, much like our exploration of the cosmos, and that, in the grand cosmic scheme of things, is a journey worth taking.